Okay, so today's lesson is lesson 2, linear and nonlinear expressions. The LEQ would be, what are our properties of linear and nonlinear expressions in X? So do you know what linear is and what nonlinear is? And then what about expressions? So let's take a look at these expressions here, okay? Pick one that would probably reflect you. I'm going to tell you that probably 5 would be my favorite one because I love to be in the water. Now, this is not the kind of expressions that we're going to be talking about in math, though. So to go ahead and get started, we're going to go ahead and take these symbolic statements. I'm sorry, these statements and write them using symbols and numbers. So here, the first one, we have 12 more than a number. So this should be a review from yesterday. Go ahead and pause the video to go ahead and answer these. All right, so welcome back. So now we have 12 more than than a number. So here we have 12, and more than means that we're going to add. And then our number, we don't know what the number is, so we're going to use the variable x to represent that. Okay, so now we have the number, and it has 12 more. Okay, the next one, the difference of a number and 45. Well, remember the meaning for difference would mean to subtract. Number is going to be x, okay, because we don't know what particular number they're saying. And then we have 45. So the difference will be x minus my 45. Next one, 5 less than 2 times a number squared. Oh, that is a mouthful. So we have 5 less than, so that's going to be minus 5. And then 2 times a number squared. So we know a number is going to, x is going to represent a number. They want us to do 2 times it. So I'm going to put a 2 here. So 2 times the number, and then we're squaring that. Okay, so to put that all together, here's my 2 times the number squared, and we're going to take away 5 of them. So minus 5. All right, so go ahead and check. Hopefully you got those all correct. We're going to continue to work with those today. Okay, let's go over some key vocabulary. You want to write these in your notes, so go ahead and freeze the video once I get finished explaining it, okay? So the very first one, all you have to do is write down the word term, and term would be the part of an equation, okay? So here's one part, which would be 3x, and then here's another part, 5. They're generally separated by addition and subtraction signs, okay? So that would be our clue. Next one is constants. Remember constants as being the same, okay? So 5 will be our constant because it's a fixed number. 5 will always represent 5. Whether it's 5 apples, 5 strawberries, it's still going to be 5. Whereas the coefficient is the number in front of the variable. Okay, so 3 would be the coefficient, and that is affected by what the value of x would be. Okay, so for the coefficient, it is going to change, but you can always find it right in front of x. All right, so the following here is we have some examples of linear and nonlinear expressions. See if you can group them, okay, and tell me what you see the difference in them. Okay, so welcome back. Now, to do that, let's see if we can make see some similarities here, okay? One of the things that I zone in right away is what equations we normally work with, okay? Those would be considered linear. So here's one we would work with here. So I'm going to put L for linear, okay? And this one also is going to be L for linear, okay? Now this one here is non-linear. Okay. So looking at those three, you have two that are linear and one that's nonlinear. What is different? What do you notice different? If you guess exponent by the on the variable, that is correct. So for it to be nonlinear, it's going to either have an exponent for x, or x is going to be in the denominator, okay, when it's a fraction. So those are the two things. So let me put it down here. So for nonlinear, x has an exponent greater than 1, or it could be less than 0. And then another way to see it is if you see the x in the denominator. So if I had like 1 over x, that would be nonlinear because that would be x to the negative 1 power. All right, so now let's see if we can go ahead and figure these out. Well, if I'm zoning right in on the x, yes, so this one would be linear. Now this has an x and then that has an x, but it's still to the power of 1, so that one would be linear. Same thing here, this one is linear. Oh my goodness, this one is non-linear. Look at that exponent right there. That's what makes it non-linear, okay? And then this one is also non-linear, okay? Because really that's going to be x to the third power and then 2 to the third power. So that would be non-linear. And then definitely this last one is non-linear. All right. So in the beginning, I made it suggestion about talking about expressions. All of these are expressions in math, okay? So they're a little bit different than equations that you've been working with. The only thing different for expressions is, guess what? They don't have an equal sign. That's the only rule, okay? So this is an expression because it doesn't say 5x plus 3 equals some number, okay? So there's no equal signs. And that's what we're going to be working with today, just expressions. All right, a linear expression is x, and an expression which in the term either constant of the product or the constant at x. So let's see if you have 5x minus 557 minus x. That's a linear expression, okay, because x is not raised to any power and there's no equal sign. Now it says y is 2, so this should be let me change my color real quick. Let's see. This should be 2x squared plus 9x plus 5. And it says, why is this expression not a linear expression? All right, hopefully you guessed it, and it was because of this exponent raised to the second power, okay? Next example, we're going to look at some of the terms. Here it says how many terms and what are they for this expression? 4 plus 3x to the fifth power. All right, so here I have 4 is one of the terms, and then 3x to the fifth power is another term. So we're looking at 2 terms. How many terms have the constant? There's only one term that has the constant. Remember, the constant is that number that does not have x associated with it, so it stays the same. So 4 would be my constant, okay? For my coefficient, there's one coefficient is that number in front of x, so 3 would be my coefficient. And then they want to know if this is linear or nonlinear. This will definitely be nonlinear because of that power is raised to the fifth power. All right, so this is our last one. This one has a little bit more than the last expression we have. We have 7x plus 9 plus 6 plus 3x. And they want to know how many terms. So here, this is one term, two terms, three terms, four terms. So four terms. And those terms would be 7x, 9, 6, and 3x. Now we can use the commutative property of addition to kind of reduce that down, which would mean to combine like terms. So I have 7x plus 3x. That's going to give me 10x. And then our addition sign, and then 9 plus 6 would give me 15. Now I'm down to just two terms. So for my coefficient, I have one term with a coefficient, which is 10. And then this is actually linear. Because when I look at my x here, there's no exponent, it's just x to the first power, okay? All right, so we're gonna go ahead and wrap it up. Remember the definitions for linear and nonlinear. Remember what an expression is also, okay? Expressions, they do not have the equal sign. And then what I would like for you to do is to email me one question that you have about this lesson. All right, see you in class.